Right, so this is just to go through how to fill your table in. So you're going to do the practical, collect the data. You can see this is the data sheet that you've got. If you can print it, brilliant. If you can't, you have to make a copy of it, I'm afraid. This is a required practical, therefore it's important that you've got evidence that you've done these practicals, and this sheet here is our evidence, or you have to write the title down and put the data down, okay? I've done 10 degrees C already, okay? And I've done test 1 and test 2 for all the temperatures. Okay, so you're just doing test 3 for 20, 30, 40, 50, 60 degrees C. You're then going to calculate a mean. Look at my mean here, 239, from a mean of, well, I've got 180, 240, 238. So you need to wonder, why did I get 239 from those 3 bits of data that I collected? What have I done there scientifically? This here is the rate, because we're interested in how fast these enzymes work, the enzymes that the bacteria would normally make. Okay, and if I divide, well, the rate, the time, basically the rate is, you know, when does it lose its pink colour? So often I'll call that 1. You know, lose its pink colour is 1, therefore we just divide 1 divided by the time in seconds, not mixed units, seconds, and then I'd get a 0.0042. Those numbers are really hard to plot. So often we do the time taken, 1 divided by the time, so seconds to the minus 1, 1 divided by time, then we just times that number by 100 to make more sensible numbers for us to plot. Now obviously you don't have graph paper, and it's a nightmare printing it because it depends on resolution of your printers. So you're going to make an accurate sketch graph. Okay, so you can use the margin in your book for this, and we're going to make each line equal, well, my highest number is going to be 0.8, as in it's not going to go above 0.8. Then I'm going to do 2 lines for 0.7, 0.6, 0.5, 0.4, and 0.3. I've no need to go any lower than 0.3 because at no rate do I have lower than that. So that's all already giving you a tip, because we now know that this axis here, the y-axis, y to the sky, is the rate of reaction. It's the result of the experiment. Okay, I'll put an x-axis on now as well. I don't label it y. Apologies. We label it with the rate of reaction. Okay, here we're going to put on the x-axis. Now I've got from 10 to 70, I've got 7 values. So, well, my ruler goes to 14. That fits on nicely, so I can just pop those on. I should be doing this the other way around slightly, but never mind. So that can be 10 degrees C, 20, 30, 40, 50, 60, 70. I didn't need the end bit. I forgot. I was starting at 10, not at 0. Yeah, there's no need to start at 0, because 0 is just an arbitrary value, isn't it, in terms of temperature? If I had to start at the actual 0, it would be minus 273. So yeah, this is my temperature in degrees C. And then you're just going to plot it. So at 10 degrees C, it was 0.42. 10 degrees C, 0.4. That's 0.45, roughly about there. So this is why it's an accurate-ish sketch graph. It's not a total sketch, because we are going to use these lines 0.4, 0.45, 0.5. I can get it in there. When you've got your data, so it's going to be faster at 20. I'm just going to chuck some points in here as well now. Then it asks you to draw a line of best fit. Remember, a line of best fit is a line that averages out the points, and it's tricky in biology when we have an N-shaped graph. So you have to kind of you have to come up and kind of go down. Don't extrapolate past the last point. So that's the graph that I want you to draw, or something similar. And then I'm going to ask you on a form to take readings from your line of best fit, so that I can check how accurate your line is, because I know what kind of data you should have got if you did this experiment carefully. So axes labelled, this done as best you can. When we're back in school and I can see your books, I'll have to kind of come around and initial these pages to show that yes, this was the required practical and you did it. Okay, good luck.